Hello and welcome to week 11 lab of IS 222. This week we are going to have our lab on MySQL, and we are going to write some advanced queries using the MySQL database. As usual, there are some notes given, so try to have a read through these notes. So this week we are mostly going to be working with these queries or commands, creating the views, working with some of the date and time functions, indexes, uh, subqueries, unions, having clause. This is similar to the where clause that we have seen in the previous labs, and continuing with joins. So again, we are given the same schema. So we are going to continue on the last week's lab. So make sure that your last lab is complete. And for the submission, you will create a file with the name lab9.sql. Write all your queries in there and drop that into this week's Dropbox. So going on to the quiz for number 1. So I'll again be using MySQL Workbench. If you don't have MySQL Workbench, then you can still continue to use the Genesis server. So number 1 says create a query to display the details of all the invoices with the invoice date format as in the example. And for that you will have to use the date format function. So it says to list the invoice number and date, and then order the result by the date. So what we need is something like this. We need the invoice number and then the date. So let's have a look at the invoice table. Okay, so in here we have the invoice date and the invoice number. So for query number 1, so query 1, we need to select the invoice number and then the invoice date, and that is in the invoice table. Okay, so we get the invoice number and the invoice date, but we want the date to be in this format. We have the day, then a comma, space, then 16th January, and so on. So from this date we need to get the day name, and for that we will need to use the date format function. So let's have a look at how the date format function works. Okay, so this is the format. We will write date format, and then inside the parentheses we are going to write the date and then which format we want. And these are some of the flags that we can use in there. So we need to format this date. So I'll write the date format function here, and the invoice date goes inside this function. Now the first parameter inside this function is the date that you want to format, which is the date from the tables over here. And the second parameter is how you want the date to be displayed. So inside quotations, you are going to write something like this. Now the first thing that we want is the day name, and the flag for the day name is you will find all the formats over here. For example, if you want the weekday name to be in 3 letters, that is something like this, so you will use % and I. And if you want the month name to be something like this in 3 letters, then you will use %B. So what we are looking for is the day name in full. So let's see if we can find that somewhere here. Okay, so this one, it says % and capital W, and that will give us the weekday name in full from Sunday to Saturday. So the flag is %W. Okay, so when I run this, you will notice that we have the day name in full. And then after that we have a comma and then a space. So we'll put a comma, space. Then we have the day of the month with this suffix, that is th. So to get that, we'll again look for the format from here. Okay, so we want something like this, day of the month as a numeric value followed by the suffix, so that is %D. Then next is space and then the month name. So to get the month name in full, we are going to use % and capital M. Then we have comma, space, and then the year. So put a comma, space, and then we have the year in full, that is a 4-digit number. So that is capital Y. So % capital Y will give the year as a numeric value in 4-digit. Right, and then now when I run this, we get the same date, but in this format. So we have day, comma, space, 16th January 2004. And the title of the column should be new date. So we'll rename that column as new date. And lastly, we need to sort the data in ascending order of the new date. So over here you will write order by new date in ascending order. Run, and that is our final result. Then next one is query number 2. In query 2, we need to create a query to display the invoice number, invoice date for each invoice, including the difference between the invoice date and that particular date, earliest as date difference. So we want the invoice number and invoice date, and we are going to find those fields in the invoice table. Right, we have invoice number and invoice date in the invoice table. So select invoice number, invoice date from the invoice table, and we get the invoice number and date. But along with the number and date, we want the difference between the date of the invoice and this particular date. And for that, we will use this date diff function. So let's see how the function works. So we will pass in 2 dates, and this will return us the difference between the 2 dates in number of days. And this is how the date function works. So it is going to do date 1 minus date 2. So if this is date 1 and this is date 2, then our result will be date 1 minus date 2. So along with all of this, we will use the date diff function, and we will pass in 2 dates. So one date would be the date from the table, that is invoice date, and the other date is the date given over here, that is 12/2/2004. But we cannot just write this directly in the query over here, because that is to go in a particular format, and the format is something like this. So we'll have the year dash month, then dash, and the date. So in our case, the date is 12/2/2004. So we are going to write something like this in our query. And then when we run the query, we get the difference between the 2 dates in the number of days. So it says the difference is -27 and -26. That is because it is doing this date minus this date. So if this date is smaller than this date, then we will get the answer in negative. So we can get the positive answer just by changing the order of this 2 date. So now it's going to do this date minus this date, and now we get the answer in positive values. The name of the column should be date underscore difference. So we can rename this as date underscore difference. Run, and we get the table. Again, we need to order the data by the ascending order of the date difference. So at the end, we will put a order by, and we are going to order it by the date difference column in ascending order. Okay, then we have query number 3. Query 3 says create an index for the product table based on the product description. Use the index name description index. The index doesn't need to be unique. But before that, why do we need indexes? So indexes are usually used for data retrieval purposes. For example, if you want to search for someone by their name on Facebook, you go there in the search bar and you write their name, right? You don't write their email address. So what the database can do is quickly search for that person in those millions of users and then return you the result. So to create the index on the table, you are going to use the create index command. Create index, and then after this you will write the name of the index. So in here the index name is description index, and then on. Now which table do you want to create this index on? That is on the product table. So you will write the name of the table, and then in parentheses you are going to write the column on which you are going to create the index. So we are creating the index on the product description. So we will write p underscore descript. Now before I run this query, what I'll do is I'll try to show the indexes from the table that we currently have, and that is using this show index command. Right, I'll run this command, and you will see that we currently have 1, 2, 3 indexes, or 3 rows that we are getting. And after I run query number 3, and now when I run this show index command, you will notice that now we have 4 indexes. and this is the one that we have just created, right? You will see that the name of the index is description index, and that is on the p description column. There's an additional question that says what is the index type for your new index, and what are all the indexes that you can see after you have created your new index. So the index type is b tree. And what is b tree? So it is a data structure. If you have done CS 112, then you might have come across this b tree. And there are some other indexes on the table. We have this product idx p description. This was created when we initially created our table. And then there is fk, and then there's this primary key. Next one is query number 4. It says create a new view called customer view that will display the customer code, customer full name, and some other details. And the brackets indicate the alias for each column. The customer should be sorted in descending order of their full name. There's some hint given. It says see the syntax for creating a view, and then we can use the show tables command to view. Okay, so what we need to do is create a view, and a view is basically just like a table. We can say it is a virtual table. And before creating a view, we will need to select some data, and then we will convert that data into a view. So before creating the view, we will select whatever data we need, and in here we need the customer code. So we are going to select the customer code. Then we have the customer full name. So if you might remember from the previous labs, we are going to use the concat function to get the full name of the customer. So we have customer first name space customer last name. Then we have the customer area code, customer phone, and customer balance. And they are coming from the customer table. Okay, so this is all we need for that view, but we also need to rename these columns. So the customer code column should be renamed as cv underscore customer code. So I'll rename the customer code column as cv underscore customer code. Then the customer name should be aliased as cv underscore name. Then we have customer area code that will be aliased as cv underscore area code. Customer phone will be aliased as cv underscore phone. And finally, the balance will be aliased as cv underscore balance. Okay, we have got some error, and let's see. Let's check the syntax. So we have a space over here. That should be one name. Run, and that is our result. Now to convert this into a view, we will use the create view command. And before creating the view, we need to sort the data in the ascending order of the customer's full name. So order by the full name is aliased as cv underscore name. Now what we need to do is whatever data we have got over here, we need to convert this into a view, right? And to create this into a view, all we need to do is go above the select command and write create view, and then we are going to give a name to this view, and the name is customer view, and we will write s. So we are saying create a customer view called customer as the data with these values. And when I run this, it says this command was executed at the bottom. You can see this green circle. And if I do a show tables command, you will see that we have this customer view. And if I select data from this customer view, then you will notice that we have the same data as we had in this select query. And you can execute all the commands that you execute on a tables. So this behaves just like a table. Then we have query number 5. Create another view to display the invoice numbers and the invoice totals for all invoices. So I think we have done this similar query in the last lab to get the invoice number and the invoice totals. So the data that we are looking for is in the lines table. So in the line table, we have the line unit, line price, and the invoice number. So to start with, let us select everything from the line table. Okay, and then to get the invoice number, we will write the invoice number column. Then to get the line total, we will do line units by line price from the line table. Okay, so we need the totals for each invoice. So we are going to sum the product of line unit and line price, and then we are going to group our result by the invoice number. Run and we get this result. The name of the column should be invoice total. So we will alias this as invoice total. Now you cannot write two separate names for a column, because in here we have invoice space total. So when you have something like that, you are going to put this inside quotation just to indicate that this is one word. So we have the invoice number and the invoice total, and then no particular ordering is required. So we have the output something like this, and you will notice that the numbers are in 2 decimal places, and in our result we have a lot of decimal points. So we need to format the output, and to format the output we are going to use a function called format, and inside that we are going to pass 2 parameters. One is the data that you want to format. So this is the one that we want to format, that is the sum. So that goes inside the format function, and then you will write the number of decimal places. So we want 2 decimal places, so I will write 2 and then run, and we get our result in 2 decimal places. So once we have the data, we can create a view from this. So once again, to create the view, you are going to use the create view command, and then the name of the view is invoice totals view. Create a view invoice totals view as this query, and then run. Then again we will show the tables from the database, and you will see that we have a view here called invoice totals view. And if I select data from this view, right, we get the same result as before, but this time this is coming from the view. Number 6 is write a query to display the information as shown the output below, and it is telling us to use the invoice, product, and the line tables to display the details for each customer in the invoice table as follows. So we want the invoice number and the invoice date. And then we want the product description for the products associated with the respective invoice number, along with the line unit and line price for that product. So this time we are going to select from 3 different tables. Now in here the table names are given, so that makes our work easier. But what if the table names were not given and only the output was given, and you were asked to get this result from the tables? So the way you do that is you will first determine the columns that you want, and that is easy. We want the customer code, number, and so on. Then the next part is to identify which tables are we going to get those data from. So customer code, where can we find the customer code? So customer code can be found in the customer table and the invoice table. So let's write down the table names. So we can get those in the customer table and the invoice table. The next one is invoice number. So we can get the invoice number in the invoice table and line table. So invoice table and line table. The next one is invoice date, and invoice date is in the invoice table. So we have invoice table here. Next one is P description, and P description is in the product table. So we have the product table in here. Then next is line unit and line price, and they are in the line table. So we have line table. Now we have 4 tables coming in here, and if you look at the schema, then this is how the tables are joined. So we have in customer, invoice, line, and product. So we have customer, invoice, line, and product. So 4 tables are joined, but from this customer table we only need the customer code, and that customer code is already in the invoice table. So we don't really need the customer table because we can get the customer code from the invoice table. So I'll remove this customer table to have minimum number of tables in my query. So we have invoice, line, and product. So we are going to select from invoice, line, and product. So these 3 tables. So once you have identified the tables, then you will need to figure out how you are going to join those tables. So we have invoice, line, and product, and they are joined like this. So you can either select the data in the tables from left to right or right to left. And then whichever order you follow, you will need to go sequentially in the schema. That means if you are going from left to right, then you will have to select from the invoice first, then line, then product. And if you are going from right to left, then you will select from product, then line, then invoice. You cannot skip any tables in between. For example, you cannot select invoice, then product, then line. You will need to follow the order. So let us go from left to right. That means we will select from the invoice table first. So select something from the invoice table, and we'll give this table a alias. Let's call it I. Now from the invoice table, we need the customer code and the invoice number. So we will write I dot customer code and I dot invoice number. Then the next column is invoice date. So 3 columns from the invoice table. Then next one is the P description. Now P description is in the product table. So we cannot directly join from the invoice table to the product table. We will first need to join on the line table and then to the product table. So from the invoice table, we are going to join on the line table. But before that, let us just run this query and see what we get. So we are getting the customer code, invoice number, and invoice date. And now we will do a left join on the line table. Now, why are we doing a left join? That is because it is saying that we want the details for each customer. That means whatever data is there in the invoice table, for every customer, we need some detail from the line and the product table. So left join on the line table, and we'll call that as L. And then we are joining on the common column, and the common column between the two tables is the invoice number. So join on I dot invoice number equals L dot invoice number. Okay, run the query and we get the same data. Now, since we have joined on the line table, now we can join on the product table to get the product description. But while we are on the line table, might as well get the details from the line table, and that is the line unit and line price. So in here we can select the line unit, so that is L dot line units, and then L dot line price. So we need the line unit and line price from the line table. Then we have P description. So now we can join on the product table since we have joined on the line table. So from the line table, we will do a join on the product table. So again, we will do a left join because we want all the invoices, and then for those invoices, we want the associated products. So left join on the product table on the common column, which is the P code. P code is in both the tables. So we will say on L dot P code equals P dot P code, and we'll rename this product table as P. Now let's run this. Okay, and we are getting the customer code, invoice number, invoice date, line unit, and line price. And the only thing that we are missing is the P description. So P description is coming from the product table, and we already have joined on the product table. So now we can select from the product table, and P description is the fourth column. So that goes after invoice date. So after invoice date, we will write P dot P description and then run the query. And we have got all the data that we needed in our query. Now it also says to sort the data in ascending order of the customer code, then the invoice number, and then the product description. Now all this while we have been sorting by only one column, but in here it says to sort by 3 columns. So let's see how we can do that. At the end, you will write the order by, and then we first need to sort the data by the customer code. So that is I dot customer code. Customer code is in the invoice table, and that has to be in ascending order. So right now the customer code is in random order. So when I run this, you will notice that the customer code is now sorted. Then after this, we are going to sort using the invoice number. So you will put a comma, and then you will write I dot invoice number. Again, this is in ascending order. Run, and we get this data. So what is happening over here is it is first going to sort by the customer code. So it will sort by this column, and we have 1001 first. So for this customer, when we sort by the invoice number, then for this customer it is going to go in those rows and then look at the data that is there in the invoice number column for this particular customer, and then within this customer it is going to sort these values. Then for the next customer, let's say customer number 12, then for this particular customer it is going to go into the invoice number column and sort the data for this particular customer. Then after this we will do the same thing but with the product description, and that is p underscore descript, and this goes in ascending order as well. So notice what happens when I run this. So right now for this particular customer, right, we have invoice numbers and we have the p description. Now notice what happens for this particular row, that is 1004. So there's only one row with the invoice number as 1002, so nothing will happen to the p description column for that. But for this 1004 there are two rows and they are not in ascending order, so we have r first, then we have c. So when we'll run this query, it is going to sort the p description for each of these invoice numbers. That means for 1004, whatever data is there in that row will be sorted in ascending order. So when I run this, you will notice that for 1004, the product description has been sorted. So it is going to first sort by the customer code. Then for that particular customer, it will sort the invoice number in ascending order. Then for each of the invoice numbers, it is going to sort the product description in ascending order. And the same happens for every other customer, invoice number and the product description. Then for number 7, it says write a query to alter the view called customer view that you created earlier to now reflect all the customers in the view with the balance of 0. And we need to retain the aliases and columns used to create customer view in question 4. Order the results by the full name in ascending order, and we need to use the alter command. So what we'll do for number 7 is bring the query from question number 4. Right, I'll copy this select command from query number 4. Right, let's run this. So we are getting this data. Then what we need to do is only select those customers who have a balance of 0. So we can filter the result after the select from table, and we will say we only want those where the customer balance is equal to 0. So these are the customers whose balance is 0. Now what we need to do is with this data we will update the view that we have created earlier in number 4. So this had all the data from the customer table. So to change or update the customer view, we are going to use the alter command. So alter view, the name of the view is customer view. So alter view customer view as the result of this select query. And then when I run this query, right, the table was altered. And when I select the data from the customer view now, you will see that we have the new data. So now it only has those customers whose balance is 0. Then for query number 8, it says recall that you had created a customer 2 table which was practically identical to customer table in one of the previous labs. You will write a select query that will combine the contents of both the tables, and we need to use the union command such that the customer 2 table details are appended to the bottom of the customer table, and no particular ordering is required. We need to use the union keyword. Now how the union command works is this is useful when you want to join two tables together, and by join we mean we need to join the data from one table into another table, that means append. So select all the rows from one table and then select rows from the other table and then append it together. Now I don't think we have the customer 2 table in here because we had dropped the customer 2 table in one of the previous labs. But what we will do is we will try to join or union the customer table with itself. So let's see what we have in the customer table. So select everything from customer. So we have all of this data. Now in here we have 10 rows. At the bottom you can see it says 10 rows retained. So when you want to union the data from two tables, you will write the select statement for one table, and then you will write the select statement for the other table, and then in between you will write the union command. Now when you are trying to use this union keyword, you need to make sure that both the tables have the same number of columns and their data type must also be same. That means if this customer table has 5 columns, then the second table also needs to have 5 columns. So since we are talking about customer 2, so we'll write customer 2. So get the data from customer table and join that with the data from the customer 2 table. But since we don't have any table called customer 2, we'll try to join customer table with itself. And when I run this query, you will notice that we get the same data as from the customer table. That is because by default it is going to remove the duplicate values. So if you want to get all the data, we can use the union all command. And now when I run this, you will notice that we are getting 20 rows at the bottom. It says 20 rows returned. That is because the data from customer table was appended to itself. So 10 from this customer table and 10 from this customer table, we take the two and join it together. Okay, so up till here we have the data from customer, the first customer table, and then from here we have data from the second customer table. Now in the similar way, you will do the remaining queries. So I have done the first 8 queries. You will do the remaining 8 or 9 queries. There are 8 queries remaining. The last query is number 17, and that is not really a query. It is just telling you to complete the remaining queries that you may have left out in the previous labs. So make sure to complete all the queries. So that is all for this week's lab. Make sure to complete all the queries and submit that in the Dropbox. So that's all for this video. Thank you for watching.